look at more examples of how to factor by grouping. This time, we're going to be looking at expressions where both of the coefficients for the x terms are negative and our constant is positive. So visually, when we try to factor this, we'll need to draw a box with 4 spaces, 1 for each term. And we'll take each of these terms and write them on the inside of our box. So we have x squared minus 5x minus 4x plus 20. When both of your x terms are negative, so you have this negative along your diagonal, the factoring process is going to be a little more complicated. Let's start by finding the greatest common factor for each row and each column. The greatest common factor of x squared and negative 5x is x. The greatest common factor between negative 4 and positive 20 is 4. The greatest common factor between x squared and negative 4x is x. And the greatest common factor between 5x and 20 is 5. However, if we go to check our answer, you'll notice that x times 5 is not equal to negative 5x. And that 4 times x is not equal to negative 4x. So we need to add negatives to each of our numbers so that we have x times negative 5 gives us negative 5x, and negative 4 times x gives us negative 4x. And since a negative times a negative is equal to a positive, we still have our positive 20. Now, writing our answer, we have the quantity of x minus 4 times the quantity of x minus 5. Now let's take a look at how to factor this expression algebraically using the grouping method. So first we'll have to split our expression into 2 groups. Our first group is the quantity x squared minus 5x. And our second group is negative 4x plus 20. Then we'll factor the greatest common factor out of each group. The greatest common factor between x squared and negative 5x is x. So we have x times x squared divided by x is x, and negative 5x divided by x is minus 5. Plus, the greatest common factor between negative 4x and 20 is 4. So we have 4 times negative 4x divided by 4 gives us minus x, plus 20 divided by 4 gives us plus 5. We don't like having this minus sign in front of our x, so we'll have to factor a negative out of our second group. We'll leave the first group the same because this already has a positive x. So we have x times the quantity x minus 5 plus 4 times negative 1. That's the negative 1 we're factoring out. So now each term on the inside of our group will have the opposite sign. Negative x divided by negative 1 gives us positive x, plus 5 divided by negative 1 gives us minus 5. And now we can recognize the common factor between each of our groups. We have this x minus 5 in each of our products, so we can factor that out. So we have the quantity x minus 5 times x times the quantity x minus 5 divided by the quantity x minus 5 leaves us with just x, plus 4 times negative 1 times the quantity x minus 5 divided by the quantity x minus 5 leaves us with just that 4 times negative 1. So our factored form is the quantity x minus 5 times the quantity x minus 4, which was the same answer we got using the other method. Let's check our answer by expanding to make sure that we get the same expression. So we'll distribute this x minus 5 to each term in the second polynomial. So we have the quantity x minus 5 times x plus the quantity of x minus 5 times negative 4. And then we'll distribute the x to each term in the x minus 5 and the negative 4 to each term in the x minus 5. X times x is x squared. X times negative 5 gives us minus 5x. Negative 4 times x gives us minus 4x. And negative 4 times negative 5 gives us plus 20. This is the same expression that we started with. So the factored form of that expression is indeed the quantity x minus 5 times the quantity x minus 4.